my name's Rachel-Bolton King, and I'm Associate Professor of Forensic Science and the course manager of Forensic Science undergraduate and postgraduate courses now at Nottingham Trent University. And my field of expertise is in firearms and ballistics. And one of the things I am really, really passionate about is trying to create more opportunities for students to learn outside the classroom, but also enabling them to use their skills and their and digital resources in more ways than we might more traditionally provide them opportunities within their sort of curriculum. And so today I want to share with you B3 because it's 3 ballistics tools that I've been sort of using and developing over recent years in the curriculum, both at undergraduate and postgraduate level, and both in an investigative and a more of a forensic science context. The QR code on the screen is just my contact details if anybody wants to reach out at any point afterwards. So when I moved to NTU, one of the draws was about our amazing forensic ballistics lab, which I have behind me, and I've put the image on the screen for you. And you know, we were really fortunate to have a range of different reference materials, really brand new comparison microscope, as well as obviously firearms, etc., for teaching, as well as sort of books and resources, reference material, etc. But how do we allow our students to develop their understanding, develop their knowledge, develop their skills in doing forensic comparison work, and really getting to grips with the complexity of looking at forensic firearm evidence? Because from all of my experience working with students, there's never enough time that we can provide them in that physical space. And we can give them the bare essentials, but even in order to help them understand whether it's for an exam or for their assessments, they need more access to those resources. And I want to turn our approach to teaching and learning away from being taught the theory to actually them being able to investigate and explore and experiment with things in a safe and controlled manner, and even from the comfort of their bed, without having the theory taught to them. I want them to be able to learn by research, learn by investigation, learn by experimentation. And I think in this particular field, which students find really, really challenging, particularly in the UK where they don't know much about firearms or forensic ballistics, I think this approach really helps them to get to grips with it a little bit better. So the 3 tools that I want to show you are World of Guns, Ballistics IQ, and Cadre's Comparison Viewer. So the first one that you can see on the screen is World of Guns. And this one in particular, it enables students to access very accurate and detailed diagrams and interact with, in a very safe and interactive manner, a range of different types of firearms. So I have a free educational license for this as an academic, and the software provider has been amazing at providing the students also with free access with a limited number of firearms that I've selected and compiled for them. So this is just one of the examples that our students utilize in the physical laboratory. But with introduction, I've been able to get them to explore using this software to really understand the mechanism of how the different firearms work, and also being able to explore and better understand the naming of the parts and what they mean. So this is the Glock 19 self-loading pistol, for example, and the software enables you to field strip it into each of its component parts, and it basically allows you to see the functioning of the weapon. It then instructs you with how to remove the magazine. You click on each of the bits, and then it takes the slide off, it takes the recoil guide spring. You can even put it in X-ray mode, and you can move it around, so you can actually see each of the component parts on the inside, which there's no way we can do easily without taking everything to bits. It's actually in the laboratory. We can also make each of the parts different colors, so that again it's more inclusive to being able to actually see what those parts are. And you can get hints about what to do next. So now the barrel comes out, etc. And that's the first step, so that they can learn to actually take the parts apart. Whereas then what we can do is actually get them to disassemble it or reassemble it, and actually test themselves in how much they've retained from that process. So this has less help and less guidance as to how to do it. You can also, in this mode, have a look at naming the parts. So you can actually click on each of the parts, and then you can see the slide, the frame, etc. And again, you can have them highlighting or not. You can see them in X-ray mode, etc. So again, a really useful tool. And there's 42 different component parts that it splits into, and the designers of this, it's also a game, so it's edutainment, so you can get points, etc., and unlock new guns, new features. But you can also look at the operation of it. And in this mode, you can slow down up to sort of 50 times, and you can click and hide different parts. So again, you can see in each of the different levels, etc. But you can have it rotating. You've got a whole range of different operations that you can do. It will show you how different features work, and then you can press so again, you can look at field stripping it, taking it apart. You can press the trigger, and then when you slow it down, the students can then see, and even you can rotate it as it's going, so that you can see the operation of the firearm. So this is a really useful sort of resource to really get them to understand the mechanisms, the different parts, and how the different types of firearms are both similar and different to each other. The second tool that I am absolutely in awe of, and I think it's an amazing opportunity to consider both the forensic science aspects of comparing fired cartridge cases, fired bullets, as well as the investigative side of gun crime and generating firearm and gun crime related intelligence, is using evidence IQ's ballistics IQ. So there's a physical 2D imaging system, which is basically a digital microscope in a box that's portable, really small. I can put it on the screen so you can see it's really tiny, it's really light, and you can literally pick it up and take it wherever you like. But basically, everything, all the images that you upload then get stored in a cloud-based software, which is what you can see on the screen. And one thing that I love immediately is the fact that you can map, so you can see where all your high gun crime, all your mock scenarios or whatever, where they're densely packed, so that from an investigative or a policing perspective, you know, you can really map the crimes that are going on in the area and help out discuss about allocating resources and things like that. So I have a research account and I have a teaching account. So again, and I can allocate licenses to and logins to my students for research purposes or for teaching purposes. And then they can access this cloud-based app wherever they are in the world, and they can spend hours, days, however long they like, exploring it, using it, and understanding the evidence that we have used in our case scenarios and the evidence they've gathered in the lab. So I mean, I can't tell you about all the functionality because there's just no time. It's that awesome. But one of the key tools from a forensic science perspective is the fact that it's got this ability, and this is what it, one of its main functions, its main purposes, is to actually look at, if you image all the fired cartridge cases at one particular crime scene, what it can do is it can analyze all of them and determine or suggest how many different firearms might have been used in that crime. And this is a crime scene analysis report that you can run. So I've just selected basically a few of the cartridge cases that are in my system within my agency at Nottingham Trent, and it just uses the Wi-Fi. So obviously the quicker your Wi-Fi, the faster this process will go. And it's the algorithm is then analyzing the images, and it's looking at saying with either high or low confidence whether each of the 4 cartridge cases that I've selected, whether they've been fired from the same gun or whether they've been fired from different guns. Then when the crime scene analysis report is generated, what it's suggesting is that there's 2 possible firearms. So it's performing triage basically, which is often performed by a human. And it's saying, okay, so of the 4 cartridge cases that you selected for me to analyze, I think all 4 of them have a high confidence that they've been fired from the same gun. Whereas this one down here, I don't think this has been fired with the same gun as these 4. I think it's with high confidence that it's been fired from a different gun. So, and I know the answer to this, and absolutely the top 4 were fired from the same gun and the bottom one wasn't. It is a relatively simple example because the class characteristics of these 2 are very different. But these 4, even though they are different ammunition, so different materials, it's still been able to group them together appropriately. So some of my students are using this as a research tool to help the company actually develop and provide more data to the system so that the algorithm can advance and so that it can differentiate between a much wider selection of different firearms and some really complicated and challenging ones as well. In terms of the final cartridge case, at the moment, it's not quite sure about this one down here. For whatever reason, it's not confident enough to say whether it was from one or other firearm or whether it's actually a completely different firearm. So again, this is hopefully where further research and development can enable the algorithm to develop and to be able to make these undetermined potentially more sort of advanced or more confident. But then further to this, we've got this comparison tool. So if I can select 2 of these different firearms, then these fired cartridge cases, then we can actually use our annotation and virtual comparison part of the software. And again, this is all built into the cloud. And so this is now allowing the students to virtually, without being in a lab, perform some aspects of comparison microscopy. Okay, we're only focusing on the head stamp region and the primer cap region. We can't see the sides of the cartridge case or some of those other forensic features that are important. However, we can get the students to understand and explore and investigate points of similarity and use the annotation tools, importantly, to actually show us and submit these in their assessments so we understand how they're coming up with their reporting conclusions. So, for example, this is a shear mark. I can unlock them. I can then bring them next to each other. I can align the class and the individual characteristics. I can lock them back again, make them smaller, bigger. etc. Can change the lighting because there's ring lighting within the actual acquisition station. Obviously, certain features will look better or worse depending on the angle of the lighting. So this one is our best viewpoint. There are a lot of other features that you can do as well, but the annotation tool is really where we can then start to, so this is one I made earlier, where it basically screen grabs the image that you can see. So you, by relaunching it, even though I've closed the computer down, by logging in as me, this has retained my previous annotations and images. So you can add new ones, for example. You could say if you wanted to label things like, I don't know, you want to say here, this is your firing pin impression, this is your drag mark. You can also change the colors, you can rename them, etc. And then you can even download each of those images so that they can be compiled in an appendices, or you can use the export function as well. So you can output a report with all of the images actually in a PDF ready for you. So loads and loads of really amazing opportunities within this piece of software to perform a lot of functions for both teaching and learning, but also for research. And if I unfilter this, if I just clear this down and I refresh my gallery, we've actually got 737 different examples. And you can now see, using the map, it's Google Earth type map, is you can see where you've actually got multiple crimes, multiple shootings in different parts of the world. So you can literally put them in any address you like. And you can also see that we're starting to investigate how we might use this imaging station as well for other types of forensic evidence, because this is one of the things I think we really struggle with, is that, you know, this particular piece of software may be just too expensive, you know, and hardware may be too expensive for a lot of universities to purchase. And therefore we might need to either work together to form collaborations so that we can teach and share resources between a consortium of universities, for example. And also we can even mimic authentic assessment and authentic work-life experiences, where you might have different agencies working on the same cross-border crime, basically. So they might have samples being uploaded into the software in one location, samples in another location or institution, and then actually working together to communicate and investigate those particular crimes. So this kind of software would also really provide us much more and greater opportunities to develop skills around collaboration, about working across different agencies or different higher education institutions, and again, not limited by geographical distance, which I think is a really exciting opportunity for the future. The final one I wanted to show you takes that 2D imaging a little bit further. And if you've got access to 3D data, so any surface topography imaging system that basically analyzes the surface, so in this case it's 2 fired bullets, and exports that data into a more common format called X3P. Forensic ballistics is using X3P as a mechanism to enable those without the original imaging station to actually open and visualize the fired bullets or the fired cartridge cases. And so this is all about the 3D data as opposed to the 2D data. But again, it's a virtual comparison microscope. So again, we can zoom in, we can move our samples around, we can move our land engraved areas we're looking at now around, and we can also use the editing feature to highlight, like we could in Ballistics IQ, where we think there are differences between our individual characteristics, for example. We can also do things like changing the lighting angle, again, so that students can explore how important the lighting is to our ability to perform and undertake comparisons a lot more easily than we can physically when we're using a comparison macroscope or a comparison microscope. We can also change the contrast within the images, which we can't do when we're looking at a physical comparison microscope. We can even change the actual scale of some of these sort of deep impression. We can actually tilt them in different orientations, and we can also rotate them. Oh no, that's some more imaging there. So let's erase some of those features. So I'll turn the annotations off. I'd recommend a mouse, though. I haven't got my mouse with me today. But yeah, we can enhance the scale, and we can also sort of export these images as well. So I've just loaded these up from my database. I've got a reference bullet, and I've got a bullet from a different firearm, and then we're literally looking at comparing the two together. So you can also look at the depth, so you can see what's lower than another, although for the bullets I tend not to find that one quite as useful. And so we can then capture those images and we can save them as well. We can then see the different we can then have a set of saved comparisons at the bottom. So that is a very quick whistle-stop tour, and this particular piece of software is Cadre Forensics Virtual Comparison Microscope. This one is much more affordable from my perspective, in terms of being able to give access to students. So it's about $500 a year, but you have a permanent license option as well. So there's loads of different sort of opportunities, different price levels, some free by working with the manufacturer or the software developer, etc. Or it's if they're beyond your own organization's sort of financial potential at the moment, I think there's greater opportunity about education institutions working together through memorandums of understanding or memorandums of understanding with the technology providers to help us also help them, but also for us to help each other and to enable our students to have better opportunities to collaborate. So I'd really like to explore with anyone who is interested in integrating cross-institutional learning opportunities in firearms and ballistics, and seeing if we can utilize the hardware, the software, etc., in a really mutual way to share the financial burden sometimes, but more importantly, to help our students develop so those authentic case scenarios, and work much more in much greater collaboration with each other. So that's kind of the key areas, the key tools that I wanted to share with you. And I mean, I've just done in Saudi Arabia another an open source intelligence focusing on firearm investigation session, which is like I'm so excited by. So these are only 3 of the tools that I use, but I'd love to hear sort of anybody who's interested in working together or any questions that anyone has to ask.